So this is my raw signal. The raw signal consists of what? So if I try to plot a signal, over here we have time t, right? And on the y-axis we have amplitude. And let us suppose, I draw a signal. But if it's an audio signal, so let us suppose we say over here, so I have a data set, right? And in the data set, we are speaking these terms 0, 1, 2, 3, up to 9. So this is what my audio data set consists of. So this becomes my classes or labels. So I am writing over here classes. These are my classes or labels. So if I look at 0, if there is a data and if this person speaks out 0, if it speaks out 1, and if I try to view that response in time domain, it would be somewhat similar to shown over here, right? You can see now that is how it looks like. So what you can see some bursts. Let me draw that burst for you. Okay, so it should be like this 0. I don't know if this color is visible to you. Let me change the color. Okay, it's not visible. Let me take green color. Okay, I think this should be visible. So there is a burst like this 0. So this is a speech signal, right? Here we are talking about speech signal. What we are supposed to do now, since this is a raw signal, we are supposed to first check whether there is a noise. If there is a noise, we need to remove the noise. Okay, so that goes into what? Pre-processing. Pre-processing, that is getting your data set ready. So once you do pre-processing, what is next? The next part would be to extract the features. Okay, features, F-E-A-T-U-R-E-S, features. Now, before you go to features, I will write down certain terms with respect to signal that we all of might have heard when we have taken a course on basic electronics engineering. Let me know if you recall certain features, right? Okay, so I'm talking about the fundamental features. So the fundamental features are, have you heard about V peak to peak, V RMS, V average? Yes, have you heard about this? V RMS, V average, and so on. You might have also come across certain features when you would have taken calculus course, or you have taken statistics course. So under statistics, you might have heard about this standard deviation, variance. Anyone recall anything? Come on, dear students, like this is the basic fundamental. We are thinking about what features we should extract from signals. Anything in chat? Let me just check. Okay, thanks, Sanjay. Okay, so there are many other features. Okay, in addition to this, you may have, kurtosis. I am writing this by K. Kurtosis, okay. Skewness, so I'm writing this as SK. Now, when working with this kind of data, it depends upon you, like what kind of features you want to extract from the data. So this will become my extracted features data set. And then this could be further combined with machine learning or AI or deep learning, ML. The second approach will be to use some statistical features that we are going to see today. So here we can apply ML. Now in both the cases, someone may say, okay, I'm not aware about the statistical features, but I am aware about V peak to peak, V RMS, V average. Can I take first approach and apply ML? Yes, you can do that. What about someone who say that, okay, now this feature extraction, VPP, VRMS, average is not going to give us a better result. And I am aware about some statistical definitions that could be applied on this data set. And we can have over here standard deviation, variation, K, and so on. Right? Someone can say, see, I know DSP. I know signal processing fundamentals. And I know that the raw features could be represented as, time frequency entity. Now, what is this time frequency entity? So here we are calling them as time frequency entity. So it could be scaleogram, right? It could be spectrogram. So if you have a raw signal, and you think of that the two approaches that we have taken are not yielding us good result, then we try to extract the raw features and put the data into time frequency. There are various methods for this representation. So now, if this is for, you can observe that this is for an audio signal. Okay, this is stop signal, right? Okay, it's speech signal. But in my data set, I have digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Are they going to look same if I try to plot time frequency? Okay, if I go to time domain representation of a signal. Come on, I think this stuff is quite interesting, right? Okay, only 2 people have answered. It's fine. Okay. Okay. Take time and think of, okay, if I have a speech signal, like what I'm speaking right now is a speech signal, and I want to represent it into time domain, how it will look like. Take a time and please answer me, okay? Because this is what we will be doing at the end. So today we'll be talking about building what you can say deep learning model. I'll take fundamentals of ML also, that's not an issue, but I want to cover deep learning part. And when we cover deep learning part, we need to understand that why we are going for time frequency. Why don't we go for amplitude time representation and extract the features that we are actually interested in? Okay, fine. Think of this. Please think of this. Let me know. Okay, what are your suggestions? Which approach I should take? Anyone has any ideas? So basically, how this signal will look like? Will there be really sorry. Anyone, any idea? Like, will that be a continuous burst of signal? So let me take a paint window and let's try to discuss this, okay? Because we'll be talking about this. So let us suppose, you want to deploy a deep learning model, or you have to receive instruction and you need to classify the actions for the robot, and the signals are go, start, stop, and so on. So we are talking that if I represent all the signals with respect to time domain, that is amplitude and time I am talking right about, will the spectrums be same? Will the time represent the amplitude time representation be same? No. Okay. So what you'll find out that if you are presentation, you'll find out that what people do is they try to go for time frequency representation. Either they will go for scaleogram. I'm not writing the full name, I'm writing scaleogram, or they may go for spectrograms. And what we are supposed to do is, we are supposed to understand that how to extract the raw features. Now we have three approaches. So this is number 3. What is the third approach? For each audio sample, represent it into time frequency, either scaleogram or spectrogram, whatever may be the method, wavelet scattering, or it may be wavelet scattering, short-term Fourier transform, or anything else. So plus, now it's your choice. Are we going to go with ML or are we going to go with deep learning? I'll come to this point, don't worry. You'll find out that the best approach will be you take time frequency representation for each audio signal. So if I have digit, now this is speech signal 0, I have 50 samples of it. This 50 samples may be into WAV format, MP3 format, any other formats do you know? You might be listening to music, .ogg format, .flsc, and so on. So I will have 50 time frequency representation. So as many samples are there, what we try to do is we try to extract the time frequency, right? So now what we are doing, we are trying to represent the audio signal into certain formats which are easy for us to understand. And then when we use deep learning over here, so what is deep learning? Deep learning will come to that point. So I'm writing deep learning. Okay, really sorry. So if I use deep learning over here, now someone can say, okay, so you have taken deep learning over here. Out of this, which approach is going to give us the best results? So the idea is like when you will do your project, when you tell someone like, okay, we want to use deep learning, or you go to a customer and like today you have voice controlled air conditions, AC turn on, turn off, temperature, set temperature to something like that. You can see that deep learning model where it is deployed. Is it deployed in the remote control? So from where it will taking audio? From the microphone, right? So someone can think of, okay, if I want to build up an application like this, where I want to control the operations using what? using speech signal. Someone will say, no, I want to make it better. So what I'll do is I will also have temperature sensors, and I will read the temperature sensor and I will set the temperature of air condition accordingly. Okay. Few of you might say, okay, what if it is connected to internet, where it actually understand the external kind of thing and then can say, okay, the external temperature is so and so, and therefore we are keeping the AC temperature to be like this. So see, it depends upon you. We need to see that out of these three approach, which one is the best. Is it fine? Any questions over here? Anything you want to ask? Because see, that is what we are going to do. Any questions? Anything you want to ask? Okay, different waveform. Sanjay. Okay, fine. Now let's try and move ahead. I'll hide this. Let's move ahead now. So one can say, like, we know these buzzwords: AI, machine learning, deep learning. So what it exactly is all about? So see, AI is a big umbrella. And what AI is, so AI is a technique, that enables a machine to mimic human intelligence. Machine learning is a subset of artificial intelligence, wherein we have some statistical method or predefined equations that help machine to learn from the data, and it does not require explicitly to program. But yes, in machine learning, you need to go for manual feature extraction, right? What is deep learning? Deep learning models, they are basically known as neural networks, wherein they are made up of a number of layers, right? So the neural network, which has certain layers, these layers will directly try to learn the features from the data that it is exposed to. Okay. So in deep learning, the task of manual feature extraction is minimized. So if you go to one slide back, see what we are saying. We are saying that if you go to ML approach, you have to work a lot on manual feature extraction. But if you go to deep learning, you can simply take over here TF representation and can apply a deep learning model to it and start training. So in the third approach, what we'll find out that the task to learn features from this data set, sample data set. So this is a data set now. This is my data. Right? So earlier I was having a data with .dap, .wav, .mp3, .occ, and .ogg, .flsc. Now I have a data which is TF. Take this approach, apply deep learning to it, the model will learn automatically. So this task of feature extraction is minimized. You might have noticed one thing. What is one thing? Who decide which features are to be extracted? An individual who has a knowledge of feature extraction or who has a knowledge of signal processing. Let us suppose you're working on images. You're working on images. So a person who has a knowledge of image processing is the one who will decide which features are to be extracted when going to ML approach. Someone can say, okay, I am from mechanical background and I want to do vibrational analysis. Can I take this kind of approach? Yes, you can take this approach. Fine. Let's go ahead. Now, we have already discussed about MATLAB desktop. I don't want to take you further into that. I have shown you what live editor is. Okay, let's get started. There are different apps to build AI model in MATLAB. Let me put up that into different category. So someone can say like, I want to use machine learning approach. So in MATLAB, you have apps and there are two apps. Okay. And the apps are classification learner app and regression learner app. Don't worry about what is classification and regression. I will be talking about that. If you feel like I want to go and use neural network approach, MATLAB supports different apps over here, which are Deep Network Designer app, okay, Deep Quantizer app. So you will try to use Deep Quantizer app when you think of compressing the neural network for deployment on a hardware where memory is a very strict parameter to us. And then we have neural net clustering, neural net fitting, and other things. Someone can say, okay, I want to go with robotics kind of thing. I want to use some control. I am building a control system application over there in my system. So you can go for reinforcement learning, that is RL. So these are the different apps available in MATLAB for us to design AI application. Now, the classification and linear regression app expect that the data should be a tabular data. Don't worry, we'll talk about this, okay, what it is. It, as I told you, here, if you're talking about audio, it could be a numeric data, that is a tabular data. It could be so on. We'll talk about this later on. Now, what we are going to learn today, how to use classification learner app, how to use regression learner app, how to use deep network designer app. So these are the three things that we need to focus on. Okay, are this the only apps that we are going to see today? No, we are going to also look at other apps. Few links I have already shared to you that will help us, in moving ahead. Any questions you have over here, you all might be waiting for from yesterday. Okay. Oh, sorry, what happened there? Okay. Fine. Next. Let us talk about this. Machine learning versus deep learning. Now see, okay, let me take a new slide over here. Okay, and let me explain you this. Let me take a new slide. Fine. Let me go with this. Okay. Purposefully, we are going with this approach because it is easier. We have two types of what you can say, if you go to machine learning, we have supervised machine learning and we have supervised machine learning. In supervised machine learning, we find out that the data is labeled. Our data is what? Labeled. How do you understand that? So if I draw a table over here, so this is my data set. I have number of columns over here. These columns are nothing but features. So I would say that from here to here, from first to n-1 column, these are x. So this is x1, x2, x3, x4, and the last column is y. So if you have a table, wherein you have this y column, so this y column is output. We say that the data is labeled. Give you the predictions. So I am saying this is y cap.